Okay, so today we're going to be talking about direct variation. And direct variation means something's proportional. This usually means that we're going to get something like a fraction. That's what proportional means. Okay, a direct variation is a special type of linear relationship. Okay, it can be expressed using the formula y equals kx. So if you notice this k, that's where we would put the slope. Okay, that's exactly what k is. And k is called the constant of variation. Okay, this is the same thing, just like we've been doing this whole entire time. This is what we call slope. Okay, in this case, it's a little bit different. Okay, so for this equation right here, it says y equals 3/4 x, or 3 over 4x, is a direct variation because it is in the form y equals kx, where k, your constant of variation, is equal to 3/4. Okay, the relationship is shown in this table. You have your y, -4 over 2, because that's what the relationship is for k. So we say -4 over 2. Well, -4 over 2 is equal to -2. -6 over 3 is -2. -8 over 4 is equal to -2. Therefore, k is equal to -2. That's how we set up our constant of variation. We take the y and we divide it by the x. And we reduce, always reduce. Okay, just like we always do, simplify. So, the value of y varies directly with x and y. Y is equal to 5 and x is equal to 2. Write an equation for the direct variation. Well, the first thing we want to do is find k. Okay, in order to find k, k is equal to y over x. And then we set up the equation where y is equal to kx. So since y is equal to 5 and x is equal to 2, this tells me k is equal to 5 over 2. That's my constant of variation, right? Constant of variation. So since I now have my k, because y is 5 and x is 2, I can now set up my equation, which is 2, step 2, the equation. Okay? We set up the equation, y equals kx, right? So therefore, replace the k with my constant of variation, which was 5 over 2. So my equation is going to be y equals 5 over 2x. Okay? All we're doing is y over x. That's my k. That's my constant variation. That's my slope, right? Same exact stuff. Okay. So let's identify a few things right here on these graphs. When I identify this graph, you'll notice right here, this is the most important piece right here. It must go through the origin. Must pass through 0, 0, right? There's the origin, right? It must go through there. Look at this one. Does this one go through 0, 0? It does not. So therefore, does not, because it does not pass through 0, 0. It's not direct variation. Okay? All right, let's see this one. Now let's look at my equations and you'll see the difference between the two. Okay, one is y equals 2x minus 1. Y is equal to 2x. Well, look at this. We have this minus 1. Okay, this minus 1 is what's going to show us differently. This is not a direct variation because it has that minus 1. Not direct variation, okay, because it has a minus 1. This one is because we're not adding or subtracting anything. We have a constant, and that's it. That's all I want. Your k is equal to 2, or in some cases, 2 over 1, right? Because we do slope, rise over run. Okay, so that is direct variation. Okay, with your tables, you want to check to see if they fit. If it's constant, 1 over 1, 3 over 2, 5 over 3, that's not constant, right? So not direct variation because it's not remaining the same. Now let's look at this one, 2 over 1, well that equals 2. 4 over 2, that equals 2. 6 over 3, that equals 2. So this is direct variation and we're good to go there. Okay, you can always graph to see if it passes through the origin. So if you want to put that down, graph to check. We'll talk more about this in the next unit, but when we have equations like this, y equals, okay? Which are direct variations equations? What is the constant of variation, okay? 1, you'll notice there's no plus or minus, so we're good to go. So 1 is direct variation, okay? Since it's direct variation, you'll notice that the 3 is my constant. So k is equal to 3, right? That is. Number 2, on the other hand, is not direct because we have this minus 5. So this is not direct variation. That's the easy peasy way to show, okay? Number 3, there's nothing added or subtracted, so this is direct variation, and my k is equal to 1 over 2. Again, number 4, we're adding 1, so therefore that's not direct variation. Really easy, okay? It should be y equals kx. That's the way direct variation works, okay? Now we're going to the next page that we have, okay? We're using direct variation for proportional continuum. We're going to look at how it is in our tables, okay? And in this case, we have this table. Determine if each of the tables represents a direct variation. If so, give the constant of variation and write an equation. Okay, so let's check it out. We got to do y over x. 4 over 2. Okay, that equals 2. 12 over 6. That equals 2. 22 over 11. That equals 2. Remember, y over x. Okay, so since we all have 2's, it's real easy. Yes, y equals 2x. And again, you can graph this in your equation and see if it goes through the origin. That's where you want to check. Next one, let's check it out. Y, again, y over x. Negative 6 over negative 2, that's a positive 3. 3 over 1, that's a positive 3. Negative 9 over 3, well, unfortunately, that's negative 3. That's different. So because of this difference, this is different from the other two. This is not direct variation, so we don't need to write the equation. Now, these are some questions you're going to see on your tests, okay, and probably on your quiz. So be careful and make sure you pay attention to this real closely. Suppose y varies directly as x. So that means it varies directly. So that means k is equal to y over x. That's your constant of variation. Write a direct variation equation that relates x and y. Well, it's telling me what x is. It's telling me what y is. So the first step is always find k. So remember, k is equal to y over x. Okay? So if that's the case, we're going to put 5.4 over 9. Okay? 5.4 over 9 equals 0.6. And we're going to go ahead and use decimals. You should be using your calculators if you can. And next, the second thing, since now we have k, that's k, right? 0.6. We write our equation. When we write our equation is always y equals kx. So in this case, y equals 0.6x. 0.6 is the k, right? So let's try it out with number 8, okay? We'll do the same thing, same setup. If x is 1.5 and y is 1. So again, first step, find k. K is equal to y over x. Y is 1, x is 1.5. Okay, type that in your calculator. I'll give you a second. If you reduce this, you might get 0.66 repeating or 2/3 as a fraction. Whichever one you want to use is okay with me. Just remember, the second time we have to write the equation. And the equation is y equals kx. Now that we found what k is, and this is k, or this is k, we can write the equation y equals 1 over 1.5, or 0.66, or 2/3 x. That's direct variation, guys. Now, this is a word problem that we're going to use, and you might see one like this on the test too. A person's weekly pay is directly, there's a word right there that you want to pay attention to, directly proportional. That means direct variation to the number of hours worked. So pay, hours worked. Okay, Eduardo's pay is $323 for 15 hours. Okay, so when we do direct variation, we're doing weekly pay over hours. Okay, so what we want to do is we want to find K. Find K. Remember, again, K is Y over X. Y in this case is weekly pay. Well, my weekly pay is $323 for 15 hours. Find the amount of pay for 35 hours. So we're going to actually solve. We're going to use direct variation in this case. Okay, so first we're going to solve the equation. Y is 323 and X is 15. So in order to find my K, we do 323 over 15. And you can use this. If it doesn't reduce, that's fine. That's your K. You can use it. It's just fine. So now we have my equation. Y equals 323 over 15x. Right? But in this case, it's telling us that he works 35 hours. Now, are hours Y or are they X? Remember, Y over X. Hours are X. So therefore, this 35 is going to get replaced with the X. That's what we're trying to solve for. So we say Y is equal to $323 over 15 times 35. And so if he worked at a rate, at the same rate, this constant rate, if it never changed, he would make $735.67. And that's how you use direct variation in real-world situations. Please make sure that you work on your worksheet. The answer key will be on my desk. And if you have any questions, feel free to ask the sub, or I will be here tomorrow.